viewers, welcome back to my channel. This is Dr. Dorcas Ngigi. This is our second lesson. In the first lesson, we started and introduced uniform circular motion. And we looked at something we called angular displacement. And what did we say is the angular displacement? This is the angle subtended at the center of the circular path. This is the angle subtended at the center of the circular path, and that angle is given in radians. And we said that that angle, if that is the circular path, and you have a body that is moving, let's say it's moving from A, that's the radius, and it's coming to another point there, let's say like C, then remember this is also a radius, don't forget. So the distance from A to C, that distance, that arc length, we called S. And we said S, when S equals to R, then the angle we subtend at the center, when S equals to R, then we subtend 1 radian, which we gave the symbol theta. Okay? When our arc length is equal to the radius, then we subtend an angle of 1 radian. So if we subtend a larger, if the arc length is bigger than the radius, if the arc length is bigger than the radius, then of course we're going to subtend more than 1 radian. And we said to know how many radians, we simply take the S and we divide by the radius to know the number of radians. So at the center, we have S over R radians. Radians, we simply give symbol theta. So S over R radians. That's what we said in our last lesson. So today, we are going to look at something else. We are going to look at angular velocity. So when you hear, anytime you hear angular, then you know we are dealing with angles. So we are talking about radians, okay? Anytime you hear angular, then you know we are talking about angles. So you expect everything to be in terms of angles. Velocity, you understand we are also talking about time here. We're talking about time, okay? So let's say, we say angular displacement we give it as S over R. So theta equals to S over R, where theta is the angular displacement in terms of radians. Pay attention. We are saying angular displacement is given in terms of angular, so it's an angle. Angular displacement is theta and is called radian. So S over R radians, okay? Okay, so if we want to get angular velocity, then it is change in that displacement, angular displacement, divided by change in time. So angular velocity equals to what? It is angular displacement divided by time. Okay? So it is change in angular displacement over change in time. Okay, angular displacement over time is simply change in, delta means change in angular displacement divided by change in time. Okay, so how do we put it now? We know angular displacement is the same as S over R. But there's something else you need to note here. As much as S is changing, S is the arc length. So as the body is going round, the S is changing, the arc length is changing. Theta is also changing. We start with 1 radian, 2 radians, 3 radians. By the time we are completing, we are 2 pi radians. But R is not changing. The angular displacement radian is changing. The arc length is also changing, but the radius of the circle is constant. So when we are putting change in, you have to remember that. So so that we say change in this equals to change in that over r. Don't forget. So angular velocity is angular displacement over time, just like linear velocity. Linear velocity is change in distance covered over change in time taken. Change in distance covered divided by change in time taken is the same here. Change in angular displacement over change in time taken, that gives us angular velocity. Okay, so we have theta equals to s over r, where theta is our angular displacement. So change in theta equals to change in s over r. I didn't put change in r because r is a constant. The radius of the circle does not change. So it is change in angular displacement is equals to change in s, where s is the arc length, divided by r. But angular velocity is change in angular displacement divided by change in time taken. So to get angular velocity now from this equation, if I must divide here by delta t and here by delta t. Okay, I must divide this by delta t and I divide this by delta t. So angular velocity equals to change in angular displacement theta over delta t, change in time taken, which is equals to what? Delta s, change in arc length over delta t over r. Okay, now angular velocity, we give it a symbol. Angular velocity, we give it a symbol. We'll give it a symbol omega. We write it as like that. Omega equals to delta s over delta t r. Okay, so this is our angular velocity. Is omega, angular velocity omega. So omega, we read it as angular velocity, we read it as omega, w, looks like a w, is delta s over delta t r. Now this makes your life easier because arc length is something you can measure, that you can measure directly. Delta t, that is you can time, and r is the radius of the circular path. So omega is the angular velocity, omega is delta s over delta t r. Where did we get that? From angular displacement, which is s over r. So change in angular displacement divided by delta t, change in time taken, gives us angular velocity. The angular velocity, we give it a symbol omega. And therefore, omega is delta s over delta t r. So the final equation we can have angular velocity times the radius, remember radius is a constant, then should be equal to delta s over delta t. That's a very important equation. So we're going to see it's important as we continue that angular velocity times r, radius, is the same as delta s, change in arc length, divided by delta t, change in time taken. So that is angular displacement. Then angular velocity is change in angular displacement divided by delta t, which is change in time taken. Why didn't we write delta r? Because r is a constant. So anytime you are getting the change, r will be a constant. So finally we have said written delta s over delta t as omega r. Now there is something I want us to think of here. As we are talking about delta s over delta t, what is delta s over delta t? Now you see, if you take if I cut this circle at that point and I cut it at that point, then take that piece on a meter rule, pay attention, take it on a ruler, then I'll measure linear length. If I take a ruler, I cut that point and I also cut that point, I take this section here on a ruler, then what I'm going to get is length, linear length. Okay, so this is equivalent to delta s over delta t is the same as delta L over delta t, change in that linear length over t. So delta S over delta T equals to V. What is V? V is linear velocity. Delta S over delta T is linear velocity. And I've explained why. Here we are dealing with change in the arc length. And an arc length is something measurable. You can cut that piece and measure on a meter rule. If you cut the whole of it, you get 2 pi times r meters. You get it in meters. Then over delta T. So whatever you get will be in meters per second. Remember, angular velocity will be in radians per second. Radians per second, because it is delta Q, where Q is in radians, over delta T, which is in seconds. So whatever you get as angular velocity, omega, is in radians per second. So remember, omega is in radians per second. But delta S over delta T, that will be in meters per second. Because when you cut that piece and put it on a ruler, what you get will be in meters. So it is in meters per second. So it is our linear velocity V. So I can substitute what is here, delta S over delta T, with V. So what we have finally, V equals to omega r. Okay? Where V is linear velocity in meters per second. Omega is angular velocity in radians per second, and r is radians in meters. Okay, so that is very important as we continue with our topic. We need to know the relationship. We need to know the relationship between linear velocity, because we are going through a linear length. As the circumference, we are covering linear length. We are also covering distance in terms of angle, so we are covering angular displacement and linear displacement, and the two are related. So if I want, angular velocity is V, linear velocity is omega r. So if I want to rewrite omega, angular velocity therefore will be V over r. Simple. Okay? It is your linear velocity divided by the radius of the circular path. That brings us to the end of our lesson. I thank you very much for listening. I hope you learned something. Don't forget to share, subscribe, but most importantly, send these to people you know will benefit from these videos. Until our next time, bye.